Hi everyone, in this video we're going to go through the first section of Chapter 8. Chapter 8 is all about consumer mathematics, so this is math that was really important for you to learn and understand because you are in fact a consumer. So this is stuff that is definitely applicable to your daily lives. In 8.1 we discuss specifically percents, taxes, and inflation. Again, all things that are really crucial to understand. So here's a list of what we'll look at in the section. You can pause and read through them if you so choose to. Hi everyone, in this video we're going to cover the first section of Chapter 8. Chapter 8 is titled Consumer Mathematics. In this chapter we're going to be exposed to lots of different stuff that is really important to you because you are in fact a consumer. So these are the things that are crucial to you as a consumer to understand and to better be aware of what's going on in your daily life. So 8.1, percents. Percents are super important to understand how they work. And these are the different topics that we're going to see in this first section, and I'll explain to you all about how these percents work. We've used percents in the past. We've seen them in the past. If you didn't know, it comes from the Latin percentum, means per hundred. Right? So that's what a percent means. 17% means 17 per 100. So we can write that 17% as 17 over 100 as a fraction, or in decimal form as 0.17. So in this first example, when we want to write our percents in decimal form, 36%, we can write it first as a fraction, 36 per 100 over 100. When I'm dividing by 100, that brings my decimal point to the left. So two places in this case, 0.36. Some people go like that, and they go once, twice to the left. If that's how it works for you, then go for it that way. Even if we have a decimal already, we're still going to bring that once, twice to the left. And so that 19.32% would be decimal point 1932. I don't typically write the 0 to the left of the decimal point, but you absolutely can if it helps. In the next two examples, we're writing decimals as percents. So my 0.29, I'm going to bring that decimal point twice to the right, and that becomes 29%. Similarly, 0.354, decimal point twice to the right, 35.4%. Now, if I need to write a fraction as a percent, sometimes I'm lucky and the fraction might already be over 100. If, in this case, 3/8, I'm just going to punch that right into my calculator. 3/8, 3 over 8 is equal to 0.375. And now I can use my decimal point, bring it twice to the right. 3/8 is 37.5%. Here we get a little bit of a wordy example, and let's see, we've got the Office of Management and Budget in the U.S. 1970, they spent $82 billion for defense, when the total federal budget was $196 billion, and then 45 years later, their spending was $598 billion, and the budget was $3.8 trillion, and they've got a little conversion there. That $3.8 trillion is, that was a terrible underline, is $3,800 billion. So they do that conversion to help you out a little bit. And then the question is, what percent of the U.S. budget was spent on in 1970 and 2015? So we need to convert these amounts to percent. So for 1970, what I'm going to do is I'm going to take the Office of Management budget, the defense budget, and I want to write that 82 million part over the total 196 billion, and then I'm going to punch that right into my calculator. 82 over 196 is equal to 0.4183, etc. So 0.418. I'm going to go to 3 decimal places. So I have my fraction now converted to a decimal in my calculator. And if I want that as a percent, because that's what the question asks me, we're going to say that is equal to 41.8%. Decimal point goes once, twice to the right. In 2015, we're going to do the exact same thing, or for 2015, we're going to do the same thing. Take our part, the defense budget, $598 billion, which is a ton of money for defense, divided by not the 3.8, but the $3,800 billion. Let me type that into my calculator. 598,3800 divided by 3800, and I get 0.15 736, etc. So I'm going 3 decimal places. 0.157, feel free to check either of those in your calculator. And then decimal point once, twice to the right, 15.7%. So they spent, let's see, 41.8% in 1970 on defense, and then 15.7% of the budget in the year 2015 was spent on defense. So it looks like it went down by quite a bit. All right, good. Next, we get to percent change. So when something changes in value or changes in amount, we sometimes will convert the percent, or compute the percent change. Okay, and so we refer to a base amount and a new amount. So when something changes in price, the base or the original price, and then the new price. And then the formula for percent change is we take the difference, new minus old. So I'm going to write this a couple of different ways. This formula here, they give it as new amount minus base amount, or new minus old, or really I just like to think of that numerator as the difference. The difference over the base amount, the difference over the old amount is kind of the most condensed way to write that formula. But things to look for, the words to look for, are when something is increasing in price or decreasing in price. The difference over the base amount is how we compute the percent change. Now, an example of percent change, we have a 12-pack of Red Bull energy drink, costs $18.02 in the year 2010, $19.58 in the year 2015. What is the percent change in the cost over this time period? Okay, so new minus old over old. This is the old, this is the new, even though that was 5 years ago. Okay, so our percent change is equal to new minus old, 1958, divided by, minus 1802, divided by 18.02. So when I do the subtraction, 1958 minus 1802 is $1.56 over the 18.02, divided by that. And I got 0.08657, so 0.0867. All right, so I went 4 decimal places in this example. And so what am I going to do? I need to take one more step because that's decimal form. So our percent change is equal to, bring that decimal point 2 places to the right, 8.67%. So the price increased by 8.67%. That's the interpretation of that there. We'll look at one more percent change example, and in this one we have an auto dealer. They're having an end of the year clearance. Their ads proclaim that their cars are only sold at a 5% markup over the dealer's cost. So this person, they have a Honda for sale, or this dealership has a Honda for sale for $23,302. On the internet, you find that the dealer cost is $21,339. Is their advertising honest? So we want to find out if that markup is actually a 5% markup, okay? And we're going to treat the new cost as the $23,000 and the old cost, right? That's the cost that the dealer, the dealer cost, as the $21,000. Okay, so our percent change is equal to new minus old, 23,302 minus 21,339 divided by old, 21,339. When I do the subtraction, I get $1,963, and then I'm going to divide that by 21,339, and in my calculator, I got 0.09199. Okay, those are some funky looking nines there. So that is equal to, let's round this to the nearest percent. That's equal to 9%. Okay, so we have disproved their 5% markup. Their advertisement is false. So that's how that works. Percent change, really just compute the difference in the numerator divided by the old, and then don't forget the step to convert it to a percent. Some formulas you will see that they have the times 100% to kind of remind you to do that. This it's not on there, but that's, you still have to take that step of writing your answer as a percent. Now we get to something called the percent equation. A lot of the time you're taught to answer percent questions as proportions. Percent over 100 equals part over total, or sometimes they do is over of. A more straightforward way to write equations involving percents, and that way we don't write them as fractions and all that, is what this is the percent equation. The percent times the base equals the amount. The percent of the total is equal to the part. That's another way to think of it there. Percent of total is the part. That's the way that makes the most sense to me to think about it. But there's always different ways to write different equations and formulas. So now we get a few examples where we're going to use that percent equation. In this first one, what is 35% of 140? And that right there with the wording, 35% of 140, that is the percent of the total, okay? So my percent, 0.35. So when I write that down in this percent equation, I got to put it in decimal form. Percent times the total equals the amount, the unknown. So in this one, 0.35 times 140, and when I type that into my calculator, 0.35 times 140, I get 49. So in this case, our unknown, our x, is equal to 49. 35% of 140 is 49, all right? You could very well write this as 35 over 100 equals x over 140. That is perfectly legit. If you prefer it that way, go for it. Next example, 63 is 18% of what number? This is the percent of the total, 0.18 times my unknown x, because I'm looking for it says what number, so 0.18 times x is equal to 63. All right, so in this case, to solve for x, I need to divide both sides by 0.18. 63 divided by 0.18. X is equal to 350. So if I fill that back into the sentence, 63 is 18% of 350. One more example where we're looking for the percent. 288 is what percent of 640? So now my x is the percent of the total. 640 equals 288. In this one, to solve for x, I divide by the 640. 288 divided by 640 is equal to 0.45. But remember, that's not the answer. That's decimal form. To get it into percent form, decimal point goes twice to the right. That's 45%. 288 is 45% of 640. Great. Now we get an application question going back to the 1995-96 Chicago Bulls. I remember this season very well. I was still a kid. I was, 11 years old. I watched, nearly all of those games. It was awesome. They had the best record in the history of the NBA, 72 wins, 10 losses. Question is, what percent of their games did they win? So to write down this percent equation, let's actually take that last sentence that doesn't have any numbers in it, but it says what percent, I'm looking for the percent, of their games, of the total, x times, well, what's the total number of games? If they had 72 wins and 10 losses, the total number of games is 82. X times 82 is equal to 72. Did they win? X times 82, what percent of their games did they win? X times 82 equals 72. To answer this one, we're going to divide both sides by 82 and then convert that decimal to 100, or to a percent. 72 over 82, X is equal to 0.878, and that, as a percent, is 87.8%. Okay, so that one a little bit more challenging because we had to know to add the 72 and the 10. The 10 didn't actually get put into that equation at all. But it could if the question asks what percent of their games did they lose. But it's always what percent, or it's always the percent times the total. So in this case, we weren't given the total, but we had to find it by adding the 72 and the 10. So when you're working on the homework in this section, what you really need to figure out in the word problems is always try to boil it down to a sentence of what percent of the total, so what thing in the problem is the total, and then equals the part. What thing in the problem is the part, and then which of those am I solving for? All right, that is the end of this section. Thank you very much for listening. Work on the homework. Let me know if you have questions, and have a wonderful day.